All right, so we're going to go over relations and functions again today. You will have a quiz on 6.1 and 6.2 on Friday. We'll go over 6.2 again tomorrow, and then you'll have some IXL time on Thursday. So you'll have time to review, and you'll have a review assignment with your IXL on Thursday. If you complete your review assignment, you will be able to use that assignment on your test Friday. They're very similar problems. So it would be beneficial for you guys to take care of that assignment and make sure you get it done. So we're going to go ahead and start with activity 1, and it should be right in your practice book, page 121. So we're going to use the mapping diagrams, and then we're going to create formulas to solve the problems. What you need to know is how to solve, or how to find the area, the perimeter, the circumference, and the volume. Okay? So those are very important formulas that you should know, because these, I think, were taught probably back in grade school. Okay, so we'll review. How do you find the area of a rectangle? Area of a rectangle, how do I find it? What do I need to do, Kevin? Base times height or length times width. Okay, so we're going to say the area is the length times the width. So we have the length of 2 and x. Okay, so to find this, I would have to multiply 2 times x. Right? So remember we talked about our input and our output. Input is the money you put into the vending machine. Output is what comes out. For it to be a relation, when you put in money, you only get 1 item out. If you get 2 items out, it's not working. It's not a function. So input, they gave you the numbers here. So what you're going to do to find your output is substitute your input for x. Get some light on this subject here. There we go. So when output is 1, that means 2 times 1, our input is 1. 2 times 1, what's my output going to be?
2.
Good, finish this one. All right, so randomly, Anthony, what is the output if x is 2? Say it again. 4, that's correct. What is the output if x is 3, Clarissa? What is the output if x is 3? Great. What is the output if x is 4, Karina? Pretty simple, right? The important part is understanding the formula, and that's where you guys are going to struggle the most. I'll do what I can to help you there, but you really need to understand the formula. So to find the perimeter for B, what do we need to do? How do I find the perimeter? No. The perimeter means I want to know the measure of this and this and this and this. So the perimeter is what it takes to go all the way around the rectangle. How do I find the perimeter, Jasmine? You're giving me the volume of a cube. Okay. So how do I find the perimeter, Nathan? It's not a multiplication problem. So it's not a multiplication problem. I need to know what it takes to go all the way around. If this is 2, what's this going to be? If this is x, what's this going to be? How do I find what it takes to go all the way around? Say again. I add 2 to what? And that's going to give me 4. So that gives me my perimeter. You're on the right track. It's not a multiplication problem. It can be, but it's not. Say it again. How do I... Okay, let me give you another example here. This is 12, this is 4, this is 12, this is 4. How do I find the perimeter of this shape? Why am I dividing? I want to know how much it takes to go all the way around. All the way around. I'm going to go 12, and I'm going to go 4, I'm going to go 12, and I'm going to go 4. What operation do I need to do in order to find the total distance? Say it again, Matthew. I need to add. So if I'm going to add, how do I find the perimeter of this one here? What do I need to add? Anybody? I'm sorry? Nathan? 2 plus 2? Is that it? Does that give me the distance all the way around? Is that it? What else? David? No, I'm not looking at this one here anymore. I'm looking at this one here. He gave me 2 plus 2 plus x for the perimeter. What do I need? What's missing, Angel? Plus x. I have to add all 4 sides. Okay, I can simplify this problem by saying 2 plus 2 is 4, x plus x is 2x. Right? So now this is my problem. So now I can substitute these numbers for x to find my output. Go ahead and do that. All right, so we have 4 plus 2 times x. So if I'm replacing x with these numbers, I get a different answer every time. When I replace x with 1, what is my output going to be? Correct. Please raise your hand. When I replace x with 2, what is my answer, Tyler? Correct. Yes, because 2 times 2 is 4, plus 4 is 8. If you're following order of operation, you're doing the multiplication before you do the addition. Okay? So when x is 3, what is my output going to be, Adam? Correct. When x is 4, what is my output going to be, Jimena? Correct. Got it? It's actually simple once you understand the order of operation and what it is that you're actually doing. For circumference, you guys don't have calculators that have a pi. So you're going to do 2 times pi times r. And you don't have a calculator that can do pi. Most of you don't. My calculators don't. We're going to use pi soon, and I really recommend that you guys get a hold of a calculator, a scientific calculator. It costs about $8 at Costco. They're pretty cheap there now. So that you can solve this when we work on volume. You will need it. Okay, so I'm going to skip C, and we're going to go ahead to D. Because D we can do. Yes, question? C is asking for circumference where you have to multiply by pi. Okay? You guys don't have a calculator where you can multiply by pi. We can use 3.14, but then you'll all have a different answer. So I'm just going to skip it altogether. So for volume of a cube, it's area cubed, right? Or I can do my base times width times height. Okay, and that'll give me the area. So once I have base times width times height. Yeah, let's not do volume. Let's do area. Too much work for you guys. All right, so we're just going to find the area of this cube. So my formula is base times width times height. So my base is what? 3. My width is what? And what's my height? So h is going to be my x, my input. Okay, so go ahead and solve your output for this one using your input of h. You understand what to do? What are we substituting these numbers for this time? H. Go ahead. All right, so let's check our answers, okay? If we're substituting correctly, we have 3 times 3, which is what?
9.
So we're really doing 9 times h to solve this problem, because 3 times 3 is not going to change, right? So what is 9 times 1? What is 9 times 2? What is 9 times 3? What is 9 times 4? Okay, so some of you guys just thought, oh, it's 9. And then all of these went up by 2, so you decided, oh, it's 11, 13. Don't assume you know the pattern. You have to do the math to do that. Understand? All right, turn your page. So this time we have 2 sets of mapping diagrams. You're going to figure out if this is you're going to figure out how many outputs are assigned to each input. Okay, so how could you figure out your output and input? What could you come up with? What could you write? How could you write them? Yesterday, your homework, you had a bunch of what? Ordered pairs? And you had to write a domain and range. So could you do the same for these guys?
Yes.
Can you turn these into ordered pairs?
Yes.
Could you also make it a domain and range?
Yes.
Okay, so what I want you guys to do is for these two, turn them into domains and range, not domain and range, ordered pairs, and then tell me if it's a function or not a function. I'll give you about 2 minutes to do these. It's really easy. Write them up as an ordered pair, and then tell me it's a function or not a function. All right, Karina. So what are my ordered pairs for A? What would my first ordered pair be?
Oh.
So it would be 12, comma 6. That's an ordered pair, right? X always before Y. Okay. My second ordered pair, Nathan, what would that be?
43, comma, and 15.
Perfect, because look at where that arrow goes to. Does not go to 13. What is my next ordered pair? Anthony. I did 12, I did 23. What's my next ordered pair? 30, 20. Remember, 30 has an arrow drawn to 20. Okay, it doesn't go straight across. And what is my last ordered pair, Ryan? Ah, look again. 13. Make sure you're going where those arrows go. So is this a function or not a function?
It is a function.
It is a function, right? So there is no cheating boyfriends, and if you put in one coin, you get 1 item out of your vending machine. So this works. Okay, so let's look at B. What's my first ordered pair for B? Excuse me. Devin, what's my first set of ordered pairs for B? Devin, eyes up here. 10 to what? 10 is 0. So it's going to be 10, comma 0. What's my second ordered pair, Ryan?
11, 0.
Ah, Do you notice my arrow is drawn to 10, 0 and 10 to 1? So what's my next ordered pair?
11, 0.
Emmanuel, what's my next ordered pair? 12 and what? And what's my next ordered pair? Christian?
12, 3.
And what's my next ordered pair? David? 2. You were right the first time. All right, so looking at these sets of ordered pairs, do I have any cheaters or repeaters?
Yeah. You got like, you got
At least 2, right?
Yeah, a couple cheaters.
10 cheats on 0 with 1 and 12 cheats on 1 with 3. But 1 is super cheating with 2. So there's a lot of cheating going on. So is this a function or not a function? Not a function. No. There is a relationship, but they're not fun. All right? So far, so good? Okay, so number 3 is about interpreting. So we have to figure out how we had an input of 1 and got an output of 8. So we need to look at the pattern. So can you guys find a pattern? Is there a pattern? It's going up by 2 every time, right? So we know that this is going to be what?
14.
And this is going to be, all right, but how do we get there?
Adding 2.
So if I added 2 to 1, I got 8? No, that didn't work. So it's a little tricky, right? 4 times 2 is what? And how do I get 14 from 8? I add 5. Let's see. Does that work here? What's 3 times 2? 6 plus 5? Nope, that doesn't work. So how do I find the equation? I can see a pattern, but I don't know how I got from 7 to 20. Yep.
20 was added by 5. 18 was added by 4.
Added by 4? What did I add by 4?
There's 8. Wait. 6.
So let's see. If I can figure out how I got 8 from 1, I added 8, right? Or I added 7. If I add 7 to 2, what do I have?
8.
9. So that doesn't work because that's not 10. If I add 7 to 3, what do I get? So there's got to be a way to get 8. Okay? Maybe I do
7 plus 1.
well, yeah, but we already tried adding 7. That didn't work. So how could I do that? Go ahead and take about 5 minutes and talk about it amongst yourselves. No, 3 minutes. And then we'll come back and see if we can figure it out. See if you can figure out how I made my input T and came out with the output of M. Okay, so if you remember, where's that other page? Here. Lord. Oh, here it is. If you remember, we had formulas for these, right? Where we substitute it. So you have to think in the same terms here. What is the formula that we're going to substitute my inputs to get these outputs? Go ahead and take 3 minutes to think about it. Talk about it amongst your group. See if you can figure it out. All right. So what I want us to look at is a change. What happens from 1 to 2? What did I do? From 1 to 2, I added 1, right? It increased by 1, correct?
Oh,
What about from 2 to 3?
1, yeah.
Increased by 1. From 3 to 4?
3.
From 3 to 4? It increased by 1. From 4 to 5? So pretty much for my input, every time it went up by 1. So let's look at my output. From 8 to 10? Plus 2. From 10 to 12? Plus 2. From 12 to 14? Plus 2. From 14 to 16? Plus 2. So if they're asking me to describe the pattern, they want to know the change. Change in T, change in M. All of these are going to be plus 2. So you can say your input went up by 1, increased by 1. And my output increased by what? By 2. Okay? So let's go ahead and look at the last one that we're going to do together. All right, so this time I have fractions, but that's fine. If I went from 1 to 2, what is my change here?
Plus 1.
So 1 to 2 is plus 1. What about 2 to 3? Plus 1. 3 to 4? Plus 1. 4 to 5? 5 to 6?
Plus 1.
They're all plus 1. So this is going to be plus 1. What is my change from 4/3 to 5/3?
Plus 1.
Plus 1?
1/3.
Plus 1/3, right? How about 5/3 to 2? Whoops, 1/3. If I went from 5/3 to 2, if I added a third, this would be 6/3, right? What's 6 divided by 3? So if I added a third, I got 2, right? So what do you think my change is going to be? Plus 1/3. So what do you think? What do you think this one would be? If this one, I turned 2 into a fraction, I made it 6/3, and I'm adding 1/3, what's this going to be? 7/3, right? What about here? What about here? Be careful. 9/3. 9 divided by 3 is? What about here?
That's going to be 10/3.
Got it?
Yeah, very simple.
Right? Well, yeah, can be. All right, go ahead and start your homework.
Thank you. Wait, what's our homework?